If you haven't done so yet, please pause the video and attempt to answer the question before listening on. In order to calculate the magnitude of the car's acceleration, we just have to consider the formula for acceleration. Now, acceleration is often written as the change in velocity divided by the change in time. We can replace the change in velocity with the following expression, where we have the final velocity minus the initial velocity. Now, the question mentions that the initial velocity is 0 and the final velocity is 24 meters per second. And then it also tells us that the change in time is 2.95 seconds. So we can plug all three values into this equation. And when we compute this, we get a value of approximately 8.14. And then the unit of acceleration would be meters per second squared. So this would be the correct answer to part A. We want to note that because the question says the car is accelerating uniformly, that this acceleration that we just figured out can be used for the subsequent parts of this question. Now, in fact, for part B, we're going to be using the same equation. The only difference is that the question is asking us how long does it take. So, of course, a question that asks how long is asking us for the amount of time that has passed. So we have to solve this equation for the delta t. And we can do that by multiplying both sides of the equation by delta t. And we'll notice that on the right-hand side, the delta t's will cancel. We could then divide both sides of the equation by the acceleration a. Now we want to remind ourselves that delta v can be written as the final velocity minus the initial velocity. And then all we have to do is plug in the known values. The question tells us that the initial velocity is 10, the final is 20, and then we computed the acceleration in part A, so we're going to plug that in the denominator. And when we plug all that into our calculator, we get a value for delta t of approximately 1.23 seconds. So this would be the correct answer to part B. Finally, to part C, will doubling the time always double the change in speed? Let's consider the acceleration formula one more time. In this case, what we want to do is solve the equation for delta v. So in order to do that, we're going to multiply both sides by delta t. And that way, on the right-hand side, the delta t's will cancel. Now, from this equation, we can see that if we took the change in time and doubled it, or multiplied it by 2, that means the quantity on the right-hand side would also have to be doubled or multiplied by 2. Well, this quantity right here is, in fact, the change in speed. And so we can see that when we double the time, or delta t, then indeed, yes, we will double the change in speed. So the correct answer to part C will be yes. And the reason is based on this equation right here. When doubling delta t, we can see that we double the delta v. Thanks for taking the time to watch the video. If you liked it, please click the thumbs up icon. Also, please subscribe to the channel so you can stay tuned for other videos. You're welcome to send your own question into this email address, and I'll do my best to post an answer to it on YouTube.